For today's lesson, we're going to determine the line of best fit for a set of data. Your lesson preview on A, you are asked to write the equation of a line given these 2 points. So that is a reminder that you might use y minus y1 equals m times x minus x1 to write the equation of a line. For question B, you need to read to pull out the points that were given within your reading. So for this problem, you have 2 points, 1, 20, and you have 2, 32. So from these 2 points, you should be able to find the slope and then write the equation of your line. So the line of best fit is a line that represents the pattern of your data. Now, as we look at lines of best fit, there are things to keep in mind. Sometimes data has no correlation at all, meaning it doesn't seem to be related. Other times, your data might have a positive correlation, which means you could draw a line through the data and it would head in an upward direction. Whereas other times, there is a negative correlation, which means that your data seems to have a correlation with a negative slope. Sometimes you can have zero slope, an undefined slope, and there are other times when you have some outliers. So outliers are individual points that do not seem to fit the pattern of your data. For example 1, Lily's working at a company that makes shirts. She's recorded the number of shirts, Y, that each of 8 employees made in one day, based on the number of months that the employees worked. So she built a scatter plot, and you want to figure out which line looks best. So as I'm looking at the first problem, the line is below the data, so it's not a good representation. The second one, okay, so this one has some data above the line and some below. However, it looks like it has more data pieces above than below. Let's see if there's a better answer. The third option, the line seems to represent the data fairly evenly. Some of your points are above, some are below, and it has a positive slope. As I look at my fourth option, there seem to be too many data points below the line of best fit. So it seems to me like our third graph might be the best line that we have drawn. So we're going to take a look at the problem and write the equation of this line. In order to write the equation of a line, we need 2 points. So let's find some nice points on this line. So for example, nice points where we're going to cross nicely. You might use 9, 9 as one of your points. And then I notice that 12, 12 looks like a good point as well. So we're going to write an equation using 9, 9 and 12, 12. So with that in mind, find your slope. Your slope would be 12 minus 9 over 12 minus 9, which is 3 over 3, or 1. Now y minus 9 equals your slope, which is 1, times x minus 9. So we have y equals 1x minus 9 plus 9. So y equals 1x is our equation. For question B, use the equation to determine how many shirts Lily could make in 100 months. Now your x value were the months at the company. So if we have y equals 1 times 100, it looks like we could make 100 shirts. And that would be great. Now for question C, when will Lily make 1,000 shirts? So we're going to let the y value equal 1,000. So if we let y equal 1,000, then that means our x must also be 1,000. The line of best fit is used to predict our different equations. So we can use the line of best fit to answer questions about these objects' relationships. So let's look at our lesson practice. Joaquin takes his bus to and from school each day. He's recorded the number of people on the bus when he gets on in the morning and the number of people on the bus when he gets on in the afternoon. So what we'd like to do is write an equation using the line of best fit. First, you should draw your line. Now we're going to draw some bad ones. Okay, so if I were to draw the line here, ooh, bad line, don't use it. Up top, no good, bad line. How about if I go, oh, no way, that doesn't represent the data. So the idea is you want to draw a line that best represents your data. You want some dots above, some dots below that line. So just draw the best you can. Everyone's going to have a slightly different answer, that's fine. Choose 2 points that are on your line. They do not have to necessarily be data points. My points are 8, 6, and 10, 8. Once you have your 2 points, you can write your equation. First, find your slope. M in my problem is 8 minus 2 divided by 10 minus 8, or 2 over 2. That comes out nicely to be 1. So we have y minus 6 equals 1 times x minus 8. There's a nice equation. Y equals 1x minus 8 plus 6 is minus 2. So we have y equals 1x minus 2 is my line of best fit. Now, this was a multiple choice question. Let's see which one seems to fit my answer the best. So as I'm looking, my slope should be around 1. So I like C and D. Those are not bad. Then you want to think about your y-intercept. My intercept is -2, which is different than theirs. So would 1 or 5 be closer? So I'm going to go with the answer is C, because I do like my slope is 1x, but I think that 1 might be a better answer for the y-intercept. For question 2, Keith is hiring a contractor to do some work in his house. He asked for 8 contractors to provide an estimate. Ooh, let's take a look. Okay, so here is our lovely graph. We want to draw the equation. We want to write the equation for the line of best fit. First, we need to draw a line. Let's put some data above, some data below. Pick 2 points that are nice points. So I've got 1 point on my line. That will be 9, 220. That's a nice point. And the other point I might use is 5 with 160. Find my slope. So the slope of my line is going to be 220 minus 60 divided by 9 minus 5. That's minus 160. And what I get is 60 divided by 4, or that comes out to be 15. So for my line, I have my y minus 160 equals my slope, which is 15 times x minus 5. Do a little bit of solving. For y, we get our 15x minus our 75. Add 160 to both sides. Y is 15x, and it looks like minus 85. All right, so let's check our answers. 15x, I like that slope, but the 50 is different. Ooh, I got a plus sign wrong. Look at that. That should be plus 85. So the reason it should be plus 85 is because I was looking at 85. So the best answer for my problem would be C. So you're going to write the equation for the line of best fit. In this case, it's draw a line in, choose your 2 values. Now for this one, once you get your value, your equation of the line, determine the temperature of the water in 20 minutes. So you're going to let x equal 20 and come up with an answer. So let's look at this problem Elizabeth's working on. So a game is being played where you attempt to toss balls through a basket. Elizabeth played the game 10 times. The scatterplot shows the percent of her tosses that successfully went into the basket. She said that her pattern is a strong negative linear correlation. So let's draw the line of best fit. There we go. Write the equation for this line. So choose some points. I like 5 with 50, and I also like 8 with 60. So those are my 2 nice points. When I write my equation, I will have my slope is 60 minus 50 over 8 minus 5, or 10 over 3. So y minus 50 equals 10 over 3 times x minus 5. Simplify. Y equals 10 thirds x minus 50 over 3 plus 50. So we've got minus 50 over 3 plus 50, and that would be equal to y equals 10 thirds x plus 100 over 3. Now, identify the error in Elizabeth's description. She said she had a negative correlation. This one, of course, is a positive correlation because your slope is positive. The line's going up. Based on this line of best fit, predict the percentage of successful tosses she will have for the 15th time she plays the game. So the number of the game is going to be 15. So 10 over 3 times 15 plus 100 over 3. So that'll be 50 plus 33, so she had 83.33% chance of successfully tossing that ball.